This is lesson 8.3, special right triangles, beginning on page 562. Number 1, find x. X is the hypotenuse of a 45, 45, 90 triangle. So the hypotenuse is equal to the leg, which is 5, times the square root of 2. Same idea with number 3. So to find x, it's the hypotenuse of a 45, 45, 90 triangle. So x is equal to the leg times the square root of 2, where the square root of 2 times the square root of 2 is 2, and 11 times 2 is 22. For number 5, we have a 30, 60, 90 right triangle, and we are given the short leg, which is 7. The hypotenuse of a 30, 60, 90 is the short leg times 2, so that will be 14, and the long leg, which is y, is equal to the short leg times the square root of 3. For number 7, Paulo is making an engraved plaque that is 3 1/4 inches high to the winner of a chess tournament. He has a mailer that is a triangular prism with 4-inch equilateral triangle bases as shown in the diagram. Will the plaque fit through the opening of the mailer? Explain. So basically what we want to know is the height of this triangle. So from here to here, vertical distance, is that greater than 3 1/4 inches, so that we'd be able to slide the plaque in there. So if we have an equilateral triangle and the side length is 4, if I split that down the middle here, then I would have a 30, 60, 90, because in an equilateral triangle, each angle is 60, and then half of 60 would be 30, and that's how we get a 30, 60, 90. So since I'm splitting this side in half, and this side is also 4, then my short leg is 2, and then to find the long leg, I multiply the short leg by the square root of 3. Which that is approximately 3.5, which is greater than 3 1/4. So yes. For number 9, to find the value of x in a 45, 45, 90, the leg is equal to the hypotenuse divided by the square root of 2. So we need to rationalize our denominator. So we'd multiply the numerator and the denominator both by the square root of 2, and we would get 15 square root of 2 over the square root of 2 times the square root of 2 is 2. For number 11, we're looking for the hypotenuse of a 45, 45, 90. We're given our leg is 18 square root of 3. So the hypotenuse is the leg times the square root of 2. And the square root of 3 times the square root of 2 is the square root of 6. For number 13, to find x, we have a 45, 45, 90, and we're looking for the hypotenuse. So the hypotenuse will always be the leg times the square root of 2. For number 15, determine the length of the leg of a 45, 45, 90 triangle with a hypotenuse length of 11. So given the hypotenuse of a 45, 45, 90, to find the leg, you have to divide by the square root of 2. So we'd have 11 over the square root of 2, which we then have to rationalize the denominator. So multiply by square root of 2 over square root of 2. And you get 11 square root of 2, and square root of 2 times square root of 2 is 2. So 11 square root of 2 over 2 would be the leg. For number 17, find the length of the hypotenuse of a 45, 45, 90 triangle with a leg length of 8 centimeters. So if you're given the leg, then to find the hypotenuse, you multiply the leg by the square root of 2. On number 19, we have a 30, 60, 90 right triangle. we were given the long leg. So the first thing that we should always do in a 30, 60, 90 is find the short leg. So the short leg times the square root of 3 is the long leg. Therefore, the long leg divided by the square root of 3 will be the short leg. So square root of 3 cancels, and x is equal to 10. Once we know what the short leg is, then we multiply it by 2 to find the hypotenuse. So y is equal to 2 times 10, which is 20. On 21, we are given the hypotenuse. So always find the short leg first. So the short leg times 2 is the hypotenuse. Therefore, the short leg will be the hypotenuse divided by 2. Once we know what the short leg is, then we multiply it by the square root of 3 to find the long leg. So x is equal to 17 over 2 times the square root of 3. Once again, we have a 30, 60, 90 right triangle. We always try to find the short leg first. So we're given the long leg in this case. So the short leg times the square root of 3 is the long leg. Therefore, the short leg is the long leg divided by the square root of 3. But we have to rationalize the denominator. So multiply by square root of 3 over square root of 3. And we get 14 square root of 3 over, and square root of 3 times square root of 3 is 3. Once we know what the short leg is, now we want to multiply that by 2 to find the hypotenuse. So 2 times 14 square root of 3 over 3 would be 28 square root of 3 over 3. For 25, find the length of the side of an equilateral triangle that has an altitude length of 24 feet. So an equilateral triangle, we have 60-degree angles, and if I split one of those angles in half, okay, this being my altitude, then I've created a 30, 60, 90 right triangle, and my altitude length, it says, is 24 feet, and we want to find the length of a side. So the length of the side will be the hypotenuse. So the first thing that we have to find is the short leg. So the short leg is the long leg divided by the square root of 3. So we rationalize that. And that would be 24 square root of 3. Square root of 3 times square root of 3 is 3. 3 goes into 24 8 times. So that would be 8 square root of 3. Once we know what the short leg is, then we multiply it by 2 to find the hypotenuse. So the hypotenuse would be 2 times 8 square root of 3, which is 16 square root of 3. So the question was asking for the length of the side. So each side would be 16 square root of 3 feet. For 27, Grace is having a party and she wants to decorate the gable of the house as shown. The gable is an isosceles right triangle, so if it's an isosceles right triangle, anytime it says that, then we know it is a 45, 45, 90 triangle. And she knows that the height of the gable is 8 feet. So that would be our leg. So our leg is 8 feet. What length of lights will she need to cover the gable below the roof line? So we want the hypotenuse here plus the hypotenuse there. So given the leg of a 45, 45, 90 triangle, we multiply it by the square root of 2 to find the hypotenuse. So if that's 8 square root of 2 and this is 8 square root of 2, then combined that would be 16 square root of 2 feet. If we wanted a decimal approximation for that, we would just multiply 16 times the square root of 2, which is 22.6. In number 29, we're given a 45, 45, 90 triangle. So each side is a 45, 45, 90 triangle. So first we would find x. We're given the hypotenuse of our 45, 45, 90. So to find x, we divide our hypotenuse by the square root of 2, and then rationalize that. So we get 6 square root of 2 over square root of 2 times square root of 2 is 2. 2 goes into 6 3 times, so we get 3 square root of 2. So that being our x, to solve for y, we know that the legs of a 45, 45, 90 are congruent. So this would also be 3 square root of 2 here and 3 square root of 2 there. In other words, 2 times 3 square root of 2, so y is equal to 2 times 3 square root of 2, which is 6 square root of 2. On 31, we see that we have an isosceles right triangle here, so that would be a 45, 45, 90. So if these angles here are 45, and we know that they're complementary because we're given the symbol for a right angle, and that means we'd have 45 degrees there, which means that we have a 45, 45, 90 right here. So we're given that the hypotenuse is 5 square root of 2. So to find x, we take the hypotenuse and we divide by the square root of 2. So the square root of 2's cancel. So x is equal to 5. And then 5 square root of 2 is a leg of this larger right triangle, which is also 45, 45, 90. So to find y, the hypotenuse, we want to take the leg and multiply by the square root of 2. And the square root of 2 times the square root of 2 is 2, and 5 times 2 is 10. Okay, since our quadrilateral has consecutive sides congruent and a right angle, then we can assume that this is a square. So we would have a 45, 45, 90 here and a 45, 45, 90 here. So x is equal to 45 degrees. Since we're given the leg is 12, then we know the legs here are 12. And to find our hypotenuse, we multiply our leg times the square root of 2. And 35, suppose a zip line is anchored in one corner of a course shaped like a rectangular prism. The other end is anchored in the opposite corner as shown. If the zip line makes a 60-degree angle with post AF, find the zip line's length AD. So for this problem, we have a 30, 60, 90, and we're given this side, which is the short leg, and we want to find this side, which is the hypotenuse. So to find the hypotenuse, we take the short leg times 2. So our answer is 50 feet. For number 37, we are given this length of 18, and on the right we have a 45, 45, 90 triangle, and 18 would be our hypotenuse. So x is our leg. So to find the leg, we take the hypotenuse and divide by the square root of 2. And then make sure to rationalize that. So we get 18 square root of 2 over 2. 2 goes into 18. And we get 9 square root of 2. To find y, we have a 30, 60, 90 triangle, 30, 60, 90. And we are given the side opposite from the 60-degree angle, so we're given the long leg. The first thing that we always do is find the short leg. So they are in a 1 to square root of 3 ratio, so if we divide the long leg by the square root of 3, that will be the short leg. So y is equal to 18 over the square root of 3, which we have to rationalize, so multiply by root 3 over root 3. And you get 18 square root of 3 over square root of 3 times square root of 3 is 3, and 3 goes into 18 6 times. So 6 square root of 3. Now that we know the short leg, we can find the hypotenuse by multiplying the short leg by 2. So that would be 12 square root of 3. The dump truck shown has a 15-foot bed length. What is the height of the bed, h, when angle x is 30 degrees, 45 degrees, and 60 degrees? So we'll start with it being 30 degrees. So if it's 30, then we would have a 30, 60, 90, and h is the short leg, and 15 is the hypotenuse. So to find the short leg, we take half of the hypotenuse, so that would be 7.5. So that's our first answer. Then, if it's 45 degrees, now we have a 45, 45, 90. And to find the leg, we divide by the square root of 2. And we have to rationalize that. And if we wanted a decimal approximation for that, we would just take 15 square root of 2 and all of that divided by 2, which is approximately 10.6. And then in our last case, if it's 60 degrees, and we know the hypotenuse is 15. So first we have to find the short leg. So we'll call that x. So to solve for x, we take half of the hypotenuse, which we can just leave as 15 over 2. And then to find the long leg, we take the short leg times the square root of 3. And we can just write that as 15 square root of 3 over 2. And if we want a decimal approximation for that, we would just type in 15 square root of 3 divided by 2, which is approximately 13 feet. For number 41, triangle XYZ is a 45, 45, 90 triangle with right angle Z. Find the coordinates of X in quadrant 1 for Y, -1, 2, and Z, 6, 2. So we'll go to our graph and plot those points. So we have Y is -1, so left 1 up 2. And we have that Z is 6, 2. So over 6 up 2 is Z. And our direction said that our right angle is at Z. and we want the coordinates of x in quadrant 1. So this is quadrant 1. So we know that it's going to be up here somewhere, and it has to be, say 45, 45, 90. Our legs are congruent, so this leg has a length of 7. So we want this other one to have a length of 7. And that would put x right there. So my x coordinate is 6, and my y coordinate would be 9. For 43, triangle JKL is a 45, 45, 90 triangle with right angle K. Find the coordinates of L in quadrant 4 for J, -3, 5, and K, -3, -2. So we'll go to our graph and plot those points. So J is at -3, 5. And K is at -3, -2. And K is our right angle. And we want the coordinates in the fourth quadrant, so this quadrant here. So our legs will be congruent since it's 45, 45, 90. So this leg is 1, 2, 3, 4, 5, 6, 7 long. So then go 7 to the right. So that puts my coordinates of L right there. So that would be to the right 4 and down 2.